Okay, now recording.
Good morning. I am Professor Udita Ratnayaka. I am one of the coordinators of this course, EEX3417, Software Development for Engineers. Today, let me start the first part of the day's school. I need screen sharing. I will cover the first part on software engineering concepts, and Mr. Neil Herat will be doing the second part on graphical user interface designing. Right. I hope you can see the screen. So what are we going to do today? In today's day school, we will be discussing why we have to learn software engineering. Then the software development life cycle, requirement engineering, software design, and designing graphical user interfaces. I hope by now you must have seen the mini project. To do the mini project, you have to go through each of these stages in the software design life cycle. So let me start by why we need software engineering. Software engineering is there because we recognize the need for a disciplined approach to software system development. And we appreciate that there are different phases in the software system development. In early days, maybe about like say 25 years ago, software engineering was almost synonymous with programming. But I hope now you must be knowing that just programming is not software engineering. The field of software engineering has evolved so much so that to design and develop a software system as a solution for any business requirement, we need to go through many stages and adhere to many standards and follow many processes. All of that are encompassed in software engineering. That is why we say when the society and the developers recognize that there need to be a disciplined approach for software system development, not ad hoc programming, this field has evolved. So in this session, you will gain a knowledge of models, methodologies, and applicable tools that can be used in each phase of the software life cycle. When you start designing or developing a software system, you must understand the importance of project management, testing, and validation when you are involved in development of a software system. And the other part, designing a proper human-user interaction, which we call HCI, is also an important part when designing software systems. Let us look at software life cycle. It includes several stages. First one, concept and feasibility. Why would you or anybody think of developing a software system? To do that, there has to be either a marketing opportunity or there has to be a need from some organization. What do we mean by this? For example, say that one of you think Excel, what we use for calculation and spreadsheeting is not good enough, but I have a great idea to make a better spreadsheet. So I think there would be a market opportunity for that, and I would be able to sell my product and maybe earn money. So that I envisage that there is a marketing opportunity if I build a new product. Otherwise, say there is an organization, a school or a university or a business entity, they want to automate their day-to-day work. So there is a need. So either there has to be a marketing opportunity or there has to be a need to start on designing a software system. That is mainly why we do this. So that phase or looking for, analyzing and studying that requirement, why is it needed, is called concept and feasibility. The second stage we call requirement capture. In requirement capture, we agree on what functions the system is to perform in consultation with the customer. That is, we have to discuss or interview the customers or go and observe their processes and find out what requirements are there to build a new system. Once we find out the requirements, then the next step is design. How will the system meet its requirements? And how, like an architect who do the design of a building to construct, to develop a software also, we need software architects to design the system. After design, we come to implementation. That is where individual modules are written in source code, compiled and integrated to build the complete system. So this is the phase or the stage that programming come into play. That is writing of the source code. And here you may have to select a programming language, whether it is Python or Java or any other new programming languages like Perl or Ruby, anything. You decide on a programming language and write the code. When you are, that is exactly the development stage or the implementation. When you are writing the program, you have to do the user documentation also. Once you do the writing or the code is written, then you have to check whether individual modules and the integrated subsystems are working properly. That is testing. In testing, mainly we look at two things. One is whether we have coded or done the program without any bugs or any faults, and verify whether the system we built meet the requirements or the expectations given by the clients or our customers. So that is the fifth phase. Do you think that's the end of it? What do you think? Is that all? Are there any more phases in the software development life cycle? Can you write your answer in the chat?
Maintain, madam.
Yes, yes, that is very important. After testing, then the next step is actually you have to release this software system to the customer and install it on their site. That we call deployment. After deployment, then still as the development team or the company that developed the software, you cannot wash your hands and go away. The process is not finished yet. There is another stage called operation and maintenance. Though you agree with the customer and make the system, there will be many things to correct later. For example, it may not be the faults or the bugs actually, because the environment change. Like, for example, the government may introduce a new tax rate. The environment, there will be different environmental laws about carbon emission, this and that may affect your system. So when that kind of changes happen, you will have to add new features or change the code, get it tested again and deploy again. So after you develop the software and deploy it, your task as the developer is not over, because most of the time the customers will come into a maintenance contract with the developing company. Afterwards, maybe say 5-10 years later, somebody is saying can't see the screen. Is there a difficulty? Can you see the screen?
Yes, we can
Yes,
see.
madam.
Somebody has posted in the chat that can't see the screen. Anyway, so because I am sharing the screen, I think it is visible. Last part or the last stage is obsolescence. That means retire and replace. Say you made an excellent piece of software, but you would have designed it for maybe the current hardware infrastructure and maybe envisioning how the infrastructure may develop in next 5 years. But can you predict what will happen in 10 years? Nobody can, right? The hardware and other system enhancements are going through a rapid process of improvements. And what you have today may not be there in 10 years' time. So you will have to take this software off and get a new software system development for for the current day hardware infrastructure and the current day requirement. So whatever you make or how good that you made the system, there will be a time that you will have to discard the software system. Therefore, when you are asked to write the phases or the stages of software development life cycle, you may write all these 8 stages or at least up to 7, even if you ignore the last one. Let us move into each of these stages now. As you saw, after concept and feasibility study, the next step is requirement engineering. It is a very important step. In requirement engineering, we look at requirement elicitation, analysis, specification, and validation. I know there are 4 new terms
we will look at each of these terms and what they mean. Out of the 8 software develop out of the 8 stages of the software development life cycle, in this course, we will be focusing on few of them. We will not going into details of all the 8, but we'll focus on few of them. Requirement engineering or the requirement analysis, this stage is 1. In this course, you should have a thorough knowledge about this requirement engineering part. Concept and feasibility part, we are not going to touch in this course. And then design stage up to some extent. We are not going into a very in-depth design. In design, we will be doing it in different as different modules. For example, when you divide the design, it may go into detailed design stages like designing user interfaces, designing databases, etc. So last day school, you would have learned databases. Now, this day school, in the second part, you will be looking at UI design. And then we have the 5th day school. It will include testing and a little bit of deployment. The other phases, we will not go into very much detail. But this is important. Requirement engineering, we will be doing in depth in this course, and there will be questions for CAT 2 as well as final exam, and you have to write this requirement engineering part in your mini project report as well. What I want to emphasize is this particular part of the software life cycle is important part of this course because we are focusing on it.
Excuse me, madam.
Yes.
මේක madam මේ UML diagram ගැන එහෙමත් කියලා දෙනවද අපිට?
UML, we are looking at one use case diagram we are going to do. Whether we will go for object class diagram or activity diagram, I have to see. I can't remember whether it is in the book. But use case diagram, definitely you have to be thorough with it. The UML use case diagram is one type of UML diagram.
Thank you, madam.
Okay. So it is widely acknowledged within software industry that software engineering projects are critically vulnerable when these activities are performed poorly. These activities mean software requirement elicitation, analysis, specification, and validation. So let us go through each of them in the next slide. Requirement elicitation. What do we mean by requirement elicitation? That is gathering or finding out what are the requirements related to making a particular system or solving a problem. Why we make a software system is to solve some problem. It could be a business problem, environmental problem, or whatever, scientific problem. So to solve that problem, we need to find out what are the requirements. That is called requirement elicitation. Elicitation means finding out, gathering, or capturing. Then requirement analysis. After we collect these requirements from the stakeholders, stakeholders mean the client, the business organization who need the software, and maybe their users, and there may be some other institutions that relate to them. So after we gather all the requirements, we have to analyze it. For this analyzing task, we may use this UML diagram and the data flow diagram. There are these two diagrams we will be focusing on this course. After analyzing, the next step is to write them down in a given format. There is a special format we call requirement specification. There is a template also. So according to that template, we write all what we learned from the elicitation stage and the analysis. This is the outcome of the requirement engineering stage, that is requirement specification, and it is the document that the client or the customer sign as the agreement between the development party and the with the development party, saying that this is the system that will, this is the requirements that will be given to them after the software is built. So that is, it is kind of a contract between the development party and the client. And finally, validation. Validation is after the software system is built, then the client or the customer would need to know whether what is built is based on what they ask. So what they ask is in the requirement specification. And at the time of requirement, write in the requirement specification, as the developer, you have to write down what are the validation steps that you need to perform when you are giving the system to the customer, because you will realize later that there is, in the testing, there is one test called acceptance test. You have to perform a set of tests to make the customer realize that what you have built is what the customer has asked. So to do that, you have to perform some test with the, you have to get the customer, go through these testing, and get the customer realize what you have built is correct and what the customer has asked for. So those things must be right in the validation document. So usually at the end of the product also, you have to look at this requirement document. So these are the 4 main stages in requirement engineering phase. Requirement elicitation, how do we do that? It is concerned where requirements come from and how the software engineer can collect them. For that, we give yes.
අර කලින් මේ හදපු ඩොකියුමන්ට් එකට මැඩම් ඒකට කියන්නේ මේ SRS ඩොකියුමන්ට් කියලා.
Oh.
Thank you.
Software requirement specification. Right? So when it comes to elicitation, that is gathering requirements, there are few techniques that we use. One is interview. You go to the place or as the developer and meet the client and interview them and try to find out what they want. Then you look at different scenarios in that in order to solve a problem. Especially say there are very few users or customers, maybe scheduling it is a scheduling activity over scientific problem, then you may have to think of different scenarios that will, so this will happen, this is how it will happen, like you will have to analyze some scenarios and find out the requirements. Prototyping is you get some input from the customer, and then there are prototyping software or tools. You can, without the functionality, you can create the user interfaces as a web page or a standalone, even as a standalone package, and you can show it to the customer. Is this what you want as the menu system? Are these the functions that you are expecting at the end of the development? So prototyping is you, without the functionality, you build the outside of whatever the customer is seeing and showing it and getting their feedback. Especially if the problem solution includes, say, a lot of graphics, maybe a real estate agent is giving you the system to automate, and you may have to show their properties or the houses, etc., which includes a lot of graphics. And it may be for general public, whatever the software is being built, and then the layman should be able to access the software very easily without a lot of complications. So in that case, it would be better, or it would be good that you can make a prototype and show it to the company that gave you the job and ask them or get their feedback. Is that what you expect? So that is what you usually do at prototyping stage. That is one way of finding requirements. Yes.
මේ prototyping එකේදී අපි code පාවිච්චි කරන්නේ නැතුව නිකන් අර මේ design tool එකකින් වගේ මේ GUI එක තියෙන විදිය වගේ එහෙම හදන එකද කරන්නේ?
Code පාවිච්චි කරන්නේ නැතුවම නෙමෙයි. There could be some prototyping tools that use code, and most of the prototyping tools are automated. You don't have to use many code. You can do it easily in a very small amount of time.
Figma කියන්නේ මට මේ වගේ මේ tool එකක්ද?
Yes, there are many tools. You will have to look for it.
Thank you.
Right? And then facilitated meetings. Facilitated meetings are also like not exactly like interviews. Say the higher management, you may have to get an appointment and get a meeting arranged. And say the company means for example, we'll think of a university. University gives the contract for a software development company to get their examination process automated. So the developer is the development company. The main party that gives the business is the university, but the user may be the students who are going to access this for see the results, etc. Then that party, the university, has to facilitate meetings with the students for the development team. Then observation. You can go to the place where the process is happening and observe how the process is being done. That's, you go there and directly observe. For requirement analysis, we use two types of techniques. One is with the UML use case diagram. The other one is with the data flow diagram. In either of these, you have to identify the business processes and identify what are the other parties or the what we call the people or the systems that interact with your system. In a data flow diagram, it's described in your book also. There is a set of symbols that you have to use. To identify a business process, you have to draw a circle. And then to show the data flowing from one process to another, there you have to use a line or arc. And then indicate who is interacting from outside, a box. And the databases with a box with one side open. In a data flow diagram, there are many levels. So what we'll do is let me give you a small problem to work on. Just read that and then we can identify how to draw a data flow diagram. We'll skip this one for a minute, that slide. Can you read this example? And then I can ask you what you identify. Right, I hope you read this. Can you identify what are the business processes here? Can somebody tell me or write on chat whether we can identify whether we are going to do a use case diagram or data flow diagram? We have to find out the processes, business processes here. Yes. When you think of a software system development, a customer taking some item from a shelf, is it part of the business process?
No, madam.
Oh, madam.
Okay, so can you identify, say, two processors that now here you have to look at not the whole process that is happening. What can you do or what can you develop as a software system? So can you tell me like one or two processors?
Okay.
So let's say we'll draw
Enter
data.
code.
Sorry?
Enter code.
Operator enters code number. Yes, okay. Okay, so that is the transaction. What do we say? Or the purchasing of the item, right? Yeah, that is one. Another one. Let me get the.
Generate bill.
Yeah, one we can say. Let me draw in the other. Okay. Purchasing process, right? If I write it here, it will go when I get the screen. What did you say the other one? This is purchase. Please make sure that on a circle in the data flow diagram, always it has to be a process. You can't write nouns like only purchase. It has to be a name of or something that is being done. Right? What did you say the other one? There is something called payment and print in the invoice, isn't it? So one process has to be the payment process. And what else? Is there anything else that we can do? Payment and print in the invoice.
Madam, our payment details ටික system එකට දාගන්න එකක් කරනවා.
Payment details, that is the purchasing process that the cashier enters the item and that what is happening at the cashier is the purchase process. And then the maybe the payment process you can separate whether you get cash or credit card, because if you are paying from the credit card, the process will be different. If you are paying from cash, the process will be something else. And then did you see that it talk about inventory? The inventory has to be updated. When somebody buys an item, inventory need to be updated. So if you look at this small example, there could be three different processes to be done. When we write like this, it is called the level 1 of the data flow diagram. And also, when you are writing a data flow diagram, you have to write on a line what is the data that flows from one process to the other. You can't write now. Within the circle, you can't write nouns. On the arc or on the line, you can't write action word. It has to be data. What kind of data that will go here? Maybe say item details. So whatever the purchase item details. Right? And here also purchase in the process, you have to reduce that item from the inventory, and then maybe the updated amount of the items has to be shown to the purchase process. Now here also you can't have this line empty. You have to have a name for it. Maybe what are the data that is flowing in between. Now here also you can say item details, because whatever being purchased, you have to reduce from the current inventory. So in the data flow diagram, you can't have standalone processors. So they have to be connected with the data that flows in between them. Then I said there are inputs and outputs. Now, out of the payment process, what is the output? What is the output from the payment process? Yes?
Generate bill.
Yeah, so the bill or the receipt, right? Generating bill is the process. So instead of payment, then you can say generate bill. Like that is the process. What comes out is the bill. And how you can differentiate is that what is inside this circle, what we call the business process, is always a verb or action word. What is here outside the business process is a noun, like bill. And then there must be tables or the databases that interact with these processes. Now we have to read and write from a database of, if it is inventory, what should be here? We have to have a database of items, isn't it? And that gets reduced or updates when the inventory is updating. And when generating the bill also, you will have to read from this file, isn't it? Because you need to know the price to generate the bill for each item. And this, the same database, you will have to refer in the purchase process also. So if it is the same file, there is a notation to indicate it is the same file. If it is just one bar, we can say it's the same file. Maybe if you want to differentiate it, say we can give 2 bars. So like that you can show that it's the same file in 2 places. What is missing in this diagram? You have the processes. You have the data that flows between processes. You have some output, and files or databases, it's both input and output. What is missing? Yes. Somebody else who did not talk so far? What is missing? Who is interacting with this system?
Manage.
Yes, manager somewhere, but especially in the purchase process, you must have the cashier somewhere, isn't it? Cashier and the user who is purchasing. So when you say the interacting party, you have a box that fully covered box. In the table, you show one side open. When it is the interacting person, we have the rectangle. Cashier and maybe the buyer. Buyer also should be in this system, right? So, and this we call a level 1 diagram, and there is a notation. We say 1, 2, 3, in the next level, say level 2 of the data flow diagram, then we can expand one of these. So for the inventory update, there could be suppliers bringing items and then reordering. So there could be, many sub-processes within the inventory update. So those things must be in the level 2 diagram. In the level 2 diagram, it could be a new page and number them as 2.1. There could be maybe like 2 or 3 circles like this with different numbering like 2.1, 2.2, 2.3, etc. Right? Is it clear? So what is, if we are going to expand the process 1, then in the next page, it should be 1.1, 1.2. Right? So this is the level 1 diagram. There is also another diagram called context diagram or the level 0 diagram. Is this clear? Right. Let us go to the next one. We didn't. Now, in the context diagram or the level 0 diagram, all that we showed in the level 1 must be in this one business process. So the purchase process, inventory update, generate bill, everything now must be within this one circle. So for that we can say supermarket. You have to give a general name then, right? For the whole system. Maybe without this, a general name like, what can we say, supermarket process or buying and selling, I think it won't do. You can find a better name. For the moment, just a general name that will give a overall idea of what is happening. Say supermarket process. And in this level 0 diagram, you have to show all the clients like buyer and the cashier, everybody here. Say unlike in the level 1 diagram. And then buyer, and here you can write the cashier here. Let me erase from here. Then check out what have we missed so far. We have to give the database, right? The database or the file that we call item or all the databases that is related to this system should be written here in the context diagram. Items, and maybe if there are any more like customer data or the cashier data, all these databases or the files should be here. And then all the outputs, the bill. If there are more outputs, that can also be here. So now do you get the idea of the context diagram? And there has to be a lines, whether it's both input or output only, you have to show by the arrow. Right? Is it clear? So when a scenario is given and you will be required to write or draw the context diagram and the level 1 diagram. That was in Cat 1 also. Right, let us go to the brief description on use case diagram. So use case diagram is a different type of a diagram which is based on object-oriented principles. But if you can master one type of diagrams, then and get that concept into your head, it will not be that difficult to draw the other type, the use case. The symbols are different. The concepts are little different, but not much. For example, in a use case diagram, also the main point is identifying the business processes, like updating the inventory, doing the purchase process, generating the bill, etc. And then, unlike the importance given for data in the data flow diagram, the importance in the use case diagram is given for the actors. Actor means the person or the system who is interacting with the system. The cashier, the buyer, the manager, all these should be drawn in the UML diagram. So what I would like you to do is draw the use case diagram for this small scenario and update it to the LMS. I will open a Dropbox and then I'll give you some feedback on what you have drawn. So let us move on to the next section. Is there any question regarding requirement analysis or this page? Because we will briefly look at design in the
Excuse me, madam.
next slide. Yes.
මේ UML diagram අදිනකොට madam අර මේ online tool එක පාවිච්චි කරාට කමක් නැහැ නේ.
කමක් නෑ. report එකක් හදනකොට. But නම් මොකද ඔයගලන්ට exam එකකට දෙනකොට අතින් අඳින්න වෙනවනේ. mini project report එකට tool එකක් use කරලා ඇඳට කමක් නෑ.
හරි, thank you.
All these sections are covered in the, I think, the second book. So please go to the second book before Cat 2. Are there any questions regarding this stage? Right, then let's move on to the requirement validation. Why we validate the requirement? I have told you before also, to make sure the software engineer has understood the requirements that are given by the customer. And it is usually based on the documents made for validation. And these requirement documents should conform to standards, and it should be understandable, consistent, and complete. So that also we will go into details how the requirements should be written. So these are the processes that we use to for the purpose of validation. Requirement review. After you write the requirement, you give it to review by the customers or the other managers and the stakeholders. As I explained earlier, the prototyping. By prototyping also, you can validate whether you have understood the requirements properly. Then the model validation, you can make a model and show it, or it is also, it could be another type of prototype. And then the acceptance test. Acceptance test is a set of tests that you should write at the requirement engineering stage, saying the client can, these tests will be given for the clients to do when the client accept the software. So these are not very complicated, though we say acceptance test. For example, say for the Open University, we need this management information system for a student registration. And what will be the acceptance test for that? Then after the software is developed, the developing company should give maybe with some dummy data the test cases to get the student registered as if it's a real student, show that when with maybe the dummy data, this is what are these are the screens that will appear when a student come to register. When a student post the application in the application portal, so this will be the data that is being asked, and these will be the verification. For example, now we don't have this OTP to verify your telephone numbers. So when the system is given to the university, the developing team should write one maybe test case to check whether the OTP is working properly. So these are the basic things that the customer would expect the development team to show them. And only if they are up to their expectation, the university would accept the software, or they can say, now the OTP is missing. Maybe you can say the email verification is there, but the telephone number verification is not there. Only the email verification is there. So you have to provide that feature also and come. So these things, but say the purposely developer does not want to give telephone number verification, then you don't write that as the acceptance test. So, but if the customer requests it, you have to. But if there is something that you don't want to write in the acceptance test, then you can avoid that and say that we are not going to give this feature. So acceptance test is that in the middle of that contract between the development team and the customer. Then there are certain practices that you need when writing good requirement. A requirement to be there should be a need or a necessity. If you are not sure why the customer needs this to be done, you have to ask it. Like, if this feature is not included, what will happen? If the customer or the stakeholder does not have a proper answer, then the feature may not be necessary. That is also, say you are not going to get telephone numbers involved, you are only going to communicate through email. Then if the customer asks for OTP for SMS, you can ask, is your stakeholder going to be using SMS or telephone messages also to interact with this system? There may be some system that it does not involve any telephone conversations. For example, say you go and try to buy a Zoom package from the portal. Everything, all the questions has to go to the help desk. And the help desk is also a web portal. And you don't have to call them, or these telephone conversations are not needed. Then there is no point verifying the customer's telephone number. So like that, if there's a doubt whether a feature or requirement is necessary, you have to ask, is there anything, what is the worst thing that could happen if this requirement is not included? And if there is no proper answer, then the customer or the stakeholder probably do not need that requirement. Then a verification. How are you going to verify it? So that is what goes into this criteria for acceptance. This step will help to ensure that the requirement is verifiable. Saying something that to include in the software system which cannot be really verified, then the customer or the development team neither cannot make sure or assure that it is being implemented in the system. Clarity. It has to be very clear. We use this word ambiguous when talking about requirement analysis and requirement gathering. Ambiguous means not clear and it can be misunderstood. So all requirement, the requirements documents and the specification when written should stand unambiguous. For that, if you can write simple sentences and very short sentences, then you can stick to clarity. Complicated and long sentences will make it ambiguous. And then there could be bad assumptions. That is, you don't know something and you assume that the customer or the stakeholder need it. So that is the common problem when writing requirements. There is also another common problem, like the customer may say how something is needed instead of what they need. For example, in that supermarket, the supermarket manager need the inventory system. So that is to get the items ordered when they are reduced and to indicate when somebody is purchasing the item is being sold out. But instead, you can't write that maintaining an item database. That is not the requirement. That is how the maintaining or creating the database is an implementation task. It is not what the customer wants. Whether you are going to have a database or maybe you give it without a relational database in some other type of database, it is part of the implementation. What the customer or the stakeholder need is getting new customers added, getting new items added. That is the requirement, not getting the database done. So when you are writing, you have to avoid the implementation details. That is how it is done, but you have to write what the stakeholder is requesting. Also, sometimes you write operations instead of writing requirements. Operations means how, say, you can say you need the printed bill. That is the requirement. how the bill is printed, you don't have to write in the requirement document. That's the operational task. Whether what kind of files to access and print the bill, you are not writing in the requirement. You have to write that the customer needs the bill to be printed at the end of the transaction. That is the requirement. How the bill is printed is not the customer's requirement. That's the operation that needs to be carried out. Then don't use incorrect terms. For that, you need write in correct grammar. And there could be missing requirements, what we call omission. Omission means something is missing. Some missing requirements happen because you are not getting the stakeholders' feedback for whether the requirements that you gathered are everything that they need. That you have to verify. Then there could be over-specifying. Over-specifying is also very complicated. So there has to be a balance between under-specifying and over-specifying, and stay in the middle ground, what they need. Under bad assumptions, you have to know that it's occurred mainly because the requirement author do not have access to sufficient information, or the information does not exist. Then you can come out of this problem by documenting all the critical information needed for that project. This is an example for writing implementation details. So assume that the specification was written for development of a requirement management tool. Now as I said, provide the database is one of the implementation detail. So don't write that provide the database. Instead, write that the customer needs to keep and update data about their students, about the exam results of the students, like that. Instead of writing the customer needs the database of student details, customer needs the database of student exam marks, like that. There are certain terms also that you should be aware of, which is actually not very clear. If you look at this sentence, the system shall support the training coordinator in defining training scenarios. Can this be implemented? When you say this word support, you are not telling the software developer what to give as the support. Instead of this kind of ambiguous words, you should be very specific, saying the system shall provide input screens for defining training scenarios, and maybe shall provide automated training scenario processors. So general or the ambiguous words like support, it is not specific enough for a developer or architect to design or develop something. Then the grammar, we already said, if you use bad grammar, then there would be a different meaning. The omission is that you miss something. So that maybe a part of the system is missing. When we talk about requirements, there are two very different types of requirements. What we discussed so far are functional requirements. Functional means what is needed for the system to function. The login, print in the receipt, backup system, inventory update, all that are part of the system to function as the uh, to that to get that supermarket model or the system implemented. Then there are a set of requirements called non-functional requirements. For example, now here the example is, say your stakeholder will say there should be fast access. So the response time of the database, security of the system, easiness of the user interface. Those are also requirements, but they are not directly implemented as functions. So those requirements in software engineering we call non-functional requirements, but they must be written in a measurable way, saying the system must respond very fast, cannot be measured. So you cannot be verified, and you cannot also make sure that it happens that way. Therefore, you have to write it in a measurable way. Like, for example, be able to access a record in 1 millisecond from a database of 30,000 records. Instead of saying to give a very secure software, you have to specify how to make the software secure. You can say to access the system, there must be user logins with user ID and passwords. There must be several tiers of user login. There could be general users, the managers, network administrator as a super user, and for the different levels, different types of access is granted. So like that, you have to say how to secure the system. Say the stakeholder say, I want the system to be very easy to use. But if you also write in the requirement document saying the system must be easy to use, how does the developer or the designer would know what to do to make it easy? Say they would do something, but then how do you get it accepted by the user? So these things has to be very specific and written in the software requirement specification. You can, when we first stakeholder ask you to say, the system must be easy to use, you can ask whether do you need only the mouse interface or whether there should be keyboard inputs, or whether it should be touch screen, or it could be in a way that maybe the data entry operators who are using the system should be able to use the system by looking at the help tab only, or reading the help tab given without any training. So like that, you can specify how easy to use this system is. Any question regarding non-functional requirements or the functional requirements? No? Right. Let's move on to design. Design is the activity after you analyze the software requirement, and it will be done as it is the main kind of the main part of the software system. In the design, there are two types. how do I say? One is the overall design, the other one is the detailed design. Overall design, sometimes you may show it with a class diagram, how the system would be functioning. In the detailed design, you have to, as I said earlier also, you have to go through the data modeling, relational database mapping, and creating the database. And then graphical user interface part. So these are the components in detailed design. And then how do you divide the system into smaller modules and get them integrated to get the integrated system. So in software design, there consists of two activities that fit into requirement analysis and construction. So the architectural design, which I said the top level design, and the detailed design. In the top level design, we describe how software is decomposed and organized into components. In the detailed design, these components allow how it is allowed for construction, like it described the specific behavior of the smaller components. For design documents, there are design notations. We are not going into depth of software design in this course. We are going into depth in requirement engineering part, but not in the design part. Here we are giving only a brief introduction what software design is. Under software design, however, since we have a major part of database design that you need to know thoroughly: data modeling, normalization, how to draw the ER diagram, and getting the relational database implemented. And also some idea of how doing the UI. In other, we are not going into details of other detailed designs like these architecture description languages. There are class and object diagrams, component diagrams, class responsibility collaborator card, deployment diagrams. All these type of creating these diagrams, it's needed for the software architect to design the software, a software system. These other types like entity relation diagrams, now you know after the third day school where we use entity relationship diagrams. There could be interface description languages. We are not going to touch on that. In earlier years, we used to teach Jackson structure charts and structure charts. Now, in the current syllabus, we are not focusing on these types of charts. They do exist, but not used anymore. Then the behavioral description or the dynamic view. In a flow chart, we are actually showing how the how some activities are carried out in order to solve a problem using an algorithm. In design stage also, there are we say a flow chart is a simple diagram. There are more advanced diagrams like activity diagrams that will depict or illustrate the behavioral description of the system. So you need to know that there are more advanced diagrams than flowchart, but we are not going to study them in this course. So we will, if we are going to study, it's only the data flow diagrams and the flow charts. And for some extent, use case diagrams as well. Right. Since I have taken like 1.5 hours, I will hand over to Mr. Neil to continue with the GUI part. Are there any questions before I leave? Right. Okay.
Okay, thank you, Professor Udita.
Thank you.
I will conduct about graphical user interface. I think you can see the graphical user interface screen here. Now, what is this graphical user interface mean? When you use computers or mobile phones or any most new electronic devices, you use a screen, hardware screen, to use this easily. Here you can see two pictures. Between the user and computer, there's a monitor. You can see this in this monitor, the graphical user interface available. This mobile graphical user interface, in mobile phones, you can touch. It has a touch screen. Here in touch screen, there are symbols. You can use these symbols to work with application software and the operating system. Actually, between hardware, when you use computers, it has hardware and software. Software you can divide operating system like system software like operating system and other application software. And both software you can use both software through this graphical user interface. The software is interface, but in that graphical user interface, hardware is the screen monitor. Now, mainly this in a graphical user interface, it has 4 components called WIMP. WIMP is Windows, icons, menus, pointers. Pointer is like I am using mouse pointer to click in icons or symbols. Here, this is pointer. This is pull down menu. These are icons. These are window. There may be several windows in a computer screen. You can control computers in a screen through these widgets. These are called widgets. These widgets are tab. Here you can see in a screen there are 3 tabs. Here this is a text box. This is label, button. You can select some from a few choices. You can select one using button, radio button. This is radio button. These all are called button, and there are different types of buttons. Submit button, radio button, like that. These are called combo box. This is called check boxes. Now, when you design user interface, you have to consider several things like color, foreground and background. When you suppose in a man or woman, the man's face is a foreground, and background, back scene is background. The size of the navigation is how to go between objects. Shape of objects, that may be circle, square, or triangle, like this. It depends on the selection of this shape, navigation, and the color should be selected according to the audience who use the screen. Arrangement of objects, grouping, that is arrangement. Resolution is number of pixels per one element. Okay, I will explain those things later. The color and foreground, foreground and background. This is the foreground. This is background. When the foreground is black, mostly blue background will be it is not good blue, because we cannot see black A through the if the foreground of this A is black, then if the background is blue, it will not clearly visible A. So here it is yellow. You can see clearly. When you prepare presentation also, you have to think about this. Size. Now there are several screen sizes. Now when these sometimes when this size is increased, the size of the character may be small. Then sometimes if the eyesight is not clear, or if some person has eye problem, so those people can't see clearly. If the screen size is, they cannot change the screen size. Some pictures also not clear when in different screen sizes. This is called aspect ratio. Aspect ratio is screen from length to width. Navigation. Navigation is from one screen to the from one screen to other screen. How we go to one screen to the other screen. This is one type is arrow. Arrows to move, folders to forward and backward. Opened folders. Here you can see folder sequence. Here you can see the icons. Resolution. Resolution is, it is in the same size screen, but the resolution is different. Here the 10 into 10, this is for example, only for example, not in real screen size. 10 into 10 is 100. Here this side 10 and this side also 10. 10 pixels per inch. This is 10 pixels per inch. Here you can see 5 pixels per inch. This is, if it is number of pixels per inch is low, it will become lowest resolution. If the number of pixels per inch is high, we call it is high resolution. Okay, 1 pixel size is smaller than this, but you see this line is clearly, you can see line is clear. Here this line is not clear. So if you see a picture from the high resolution, it will be clear than this low resolution pixel size. But sometimes low resolution is good because memory for this low resolution is less than this high resolution. We use colors in computer screen. Here now these are primary keys. Red, blue, green is primary keys. Okay. Now combining this blue and green become cyan. Combining this blue and red become magenta. Combining this red and green become yellow. These are called secondary colors. Secondary color magenta, cyan and yellow. Primary colors are red, green, blue. Now, when you when the monitor, the computer screen has this type of 3 pixels. Each pixel have 3 elements called red, blue, and green in the computer screen. You can't see, but there are small 3 elements in a 1 pixel for blue, red and green. When a value of the blue is increase or decrease, in in three of these elements, when each of these elements value can be changed from 0 to 255 from each element, then these colors will be changed according to when you change the value. Lightness is range from dark to full illuminate. Now this side is black and this side is 0. In this, here you can see when one color can be changed from adding black and reduced without reducing without the black. Brightness is relative lightness or darkness of a particular color. Saturation, that also adding white, that early one is adding black, that is adding white to this color. It becomes we call it as a saturation. The warm and cool colors. Warm colors are red, yellow and orange. Here this side is, you can see this circle. These are warm colors, these are cool colors. Warm colors are like fire, and the cool colors are like blue. Mainly here you can see blue. Blue color is like water. In sea water, blue color is available. In fire, you can see red color. These are mainly warm color and cool color. When you design a website or graphical user interface, you have to think about these colors and the sizes, and the other thing is grouping. When you we call when you design when you grouping icons and those symbols, you have to think about this Gestalt theory. 5 important laws for designing a graphical user interface are continuation, closure, figure, ground, proximity and similarity. Actually, you can see in your book, here these are Gestalt theory, continuation. You can see all these are dots, but in like a group, you can see there are 2 lines. One is straight line and the other is one curve with divided by red and black, like that. But actually, what is this? Set of circles. Closer. These are not. As you can see, you can think about this as triangle, but this is not a triangle. This is just a circle cut here, from cut here. Here also there. Here you cannot continuation of this lines. But you think about this. This is like a animal. Foreground and background. You can think here about two pictures, either two faces or one vase. Proximity. You can group one circles in a close together, so you can think about this. All these icons become a same group, that is closer. Here left side is, if you screen like this, we think, but may actually not, but we think this is related to the one topic, or this is related to the other topic. That you see, when you see it, you will think. May not, but may not actually same. But here similarity. These are squares. But you think here these squares are similar and these circles are similar. And here regarding the colors, primary, secondary and tertiary. Earlier I discussed about primary and secondary. Primary is red, blue, green. Secondary is yellow, magenta, blue, yellow, magenta and cyan. Between those things, blue and cyan, you can see this color. Blue and magenta, there is another color, that is tertiary colors. Do you have any questions regarding this also this about this graphical user interface and day school and what? Can you chat? What are the problems? How about cat 1? Now you have to do the lab 3 also. I didn't well me. A mini project. Is there a quiz in lab 3? Yes. For the lab 3, there is a quiz. What about mini project? Mini project includes database and you have to design use case and the data flow, ERD diagram, and for the given scenarios. What is incursion? I didn't well mean some problem with me. Some problem with you. Tell me any questions. Okay. Try other cat pen lab, because we are looking for the best cat, no? So you can do other cat. Lab 3 about I think lab sheet is available. SAMP or WAMP server, you can yourself install SAMP or WAMP. Then how to install this? I included in LMS, and do the lab sheet. Then you can easily do the test. A mini project has ERD diagram. We will give scenarios, some few scenarios, and then you have we will group according randomly group, and according to the group you can see the scenario. According to that scenario, you have to do the requirement analysis, data flow diagram, and the use case diagram, and the ERT diagram, and implement using the like that SAMP. Can okay, I will give recording.